Here we're looking at example 1 where we're going to let f of x equal the absolute value of x and g of x is equal to this x squared plus 1, and we're trying to find the limit as x approaches 2 of f of g of x, so kind of that composition of functions. Now before we can actually dive into example 1, we first have to kind of show something through one of the theorems dealing with continuity. Now we're going to suppose that the limit as x approaches a of g of x, specifically g of x, is equal to some limit. So in other words, this limit does in fact exist, and f is continuous specifically at that limit. Then as a result, we can say that the limit as x approaches that value a of f of g of x, in other words, the composition of these two functions, is the exact same thing as saying f times the limit as x approaches a of just g of x, which is just the same thing as saying f of that limit. In other words, just finding that limit, going ahead and throwing it then into that function f. Alright, so it's kind of like an analogy back to like the nth even root, or I'm sorry, the nth roots, or the power property when we were talking about operations with limits. So that's kind of an analogy that you can do, just kind of throw out that function on the outside of that limit. There is also a corollary that kind of goes along with this, and it has to do with continuity. Suppose that g is a continuous function and at specifically this value a, and f is also continuous at g of a, then the composition f of g of x must also be continuous at a. Again, that's just kind of like the transitive property in mathematics that we've seen in the past, but it has to deal with things just being continuous and like compounding continuity. Then the outside most function would also be continuous as well. Now looking at example 1, we can go ahead and answer these questions. The limit as x approaches 2 of f of g of x. Well, again, according to our theorem dealing with continuity with functions, says that we can bypass this f function, apply this limit to our g function as we see here, find this specific limit, and then basically plug that into our f function. So in example 1, we can see that we are going to go ahead and take our limit, apply it to our g function. So then it looks like we end up with f of the limit as x approaches 2 of our g function, x squared plus 1, which is the exact same thing as saying f of the limit as x approaches 2 of this x squared plus 1. Well, if you go ahead and use direct evaluation, you end up with 4 plus 1 is just 5. And now we can go ahead and just throw in that value into our f function. So as a result, looks like we end up with the absolute value of 5, and the absolute value of 5 just simply comes out to be 5. So again, that is example 1 and kind of using that theorem with the composition of functions and how they work with limits.